Topic 4.2, Applications of Maxima and Minima. Here we have two rectangular gardens with a total of 81 square feet in the area shown. The rectangle to the right here has half the length of the rectangle to the left. We want to find the smallest perimeter. Okay, let's redraw this and start labeling it, and then we'll see if we can find the smallest perimeter. Okay, there's my rectangle. And it looks almost about half. Okay. And now I want to start labeling the sides, because for perimeter we need to know the length of each side. This first side is unknown, we'll call it X. The next side from here to here is also unknown, we'll call that Y. This side is known to be half of the one to the left, so we'll call that 1/2 Y. From here to here will be the same length as X. The top of this will be also 1/2 Y. And from here to here will be the value of Y. Okay. Using these labels, I'm going to find my perimeter. My perimeter will be made out of a total of 2 X's on this side here. So X plus X. It will also be made out of a total of 2 Y's. So Y plus Y. And it will be made out of a total of 2 half Y's. So plus half Y plus 1/2 Y. Okay, I want to simplify this into perimeter is made out of 2X, 2 Y's plus another Y. That makes a total of 3 Y's. Okay, so the perimeter can be found by multiplying this side by 2 and this Y right here by 3. Okay, now furthermore, to find the minimum values or maximum values, we have to take the derivative of the function and solve that function for 0 to find the critical points. The critical points will give us max or min points. This function is made out of X's and Y's, and I don't want to take a derivative of it because I can only take a derivative of it with respect to one variable. So one of these variables has to go. The way that I'm going to replace one of these variables is to find more information about this rectangle that's more permanent. We know that the area is going to be 81 square feet, and we know the area formula for any rectangle. The area formula for any rectangle will be base times the height. In our case here, the area is set at 81, so we can replace the area with 81. The base is from here to here, which is made out of Y and 1/2 of Y. The height of this rectangle is from here to here, which is X. Now I'm going to simplify this. I have a Y, a single Y plus 1/2 Y. This will add to 3/2 Y. Times X. So 81 equals 3/2 X times Y. I'll continue to simplify this by getting rid of the 2 by multiplying both sides by 2, or the 2 as the denominator here. This now gives me 162 equals 3 times Y times X. Furthermore, I'm going to divide everything by 3. I end up with 54 equals yx. Now, I'm going to solve for y so that this y here can be replaced in terms of x. So this implies that y is 54 over x. So I'll substitute this y here for 54 over x. Doing so will put this entire function in terms of x. So I introduce p of x, saying this is a function now of x, if now that I have 2x plus 3 times 54 over x. And this prepares me to take a derivative of this function because it's only in terms of x. Now, I'm going to do a little more cleanup here. I'm going to simplify this, but I want to write the x as a power, with a power, because we want to take a derivative next. So just kind of preparing that. So now we have the perimeter is equal to 2x plus 162 times x to the negative second power. Now I'll take a derivative of p with respect to x. Okay, now I'm going to set the derivative here equal to 0 and solve for x. Because I'm now solving for x, I no longer need the power of x here. So I'm going to convert that back into a rational. So it's going to go back into the denominator. Okay. Now, to continue solving for x, I'm going to basically bring this negative 162 to the left side, making it a positive 162 over x squared. So now that I have 162 over x squared equals 2, I'm going to multiply both sides by x squared. This gives me 162 equals 2x squared. Now I'm going to divide both sides by 2. And that gives me 81 equals x squared. From here I'll take the square root of both sides, and I'll take the principal root, which will give me a positive 9. I won't use the negative 9 because we're talking about distance here, so the domain of my x and y will not be negative numbers because we don't want to count in a real world situation distances as negative. Now that I have x is 9, I'm going to find y, because y is defined as 54 divided by 9. Which gives me that y is going to be 6. So now I can answer my original question. Find the smallest perimeter. Well, the smallest perimeter will be found by 2 times x and 3 times y. 2 times my x is 2 times 9, and 3 times my y is 3 times 6. This is going to be 18 plus 18.